everyone, this is Selva Brinda, Assistant Professor, Department of Artificial Intelligence and Data Science from Ramco Institute of Technology, Rajapalem. In this lecture, we are going to explore some of the basic concepts of bubble shorting. So, we are going to understand how bubble shorting works and analyze its time complexity. Now, let us have an introduction to bubble short. So, what is bubble short? Bubble short is nothing but a simple comparison based shorting algorithm. So, this algorithm repeatedly steps through the list to be shorted, compares each pair of adjacent elements, and swap them if they are in wrong order. So, it is called as bubble sort because it is similar to the movement of an air bubble that rises up in the water. So, the larger bubble will rise first, and the smaller ones will flow into it. So, likewise, in bubble shot, the larger element in the list bubble up to its correct position in each iteration. So here comes the working of bubble shot. So the bubble shot starts with the first element. It compares the current element with the next element. If the current element is greater than the next element, then both the elements are swapped. If not, move to the next element. So repeat the steps 1 to 3 until we get the shorted list. To understand the working of bubble sort algorithm, let us take an unsorted array. So the elements of unsorted array is 5, 3, 8, 6, 7 and 2. So now in iteration 1, we start with the initially two elements that is 5 and 3. Compare both and check which one is greater. So here 5 is greater than 3. So swapping happens here. That is 5 is replaced by 3 and 3 is replaced by 5. Then the next two elements that is 5 and 8 is compared. So here it is in the proper order, so no swapping is required. Next, the next two elements 8 and 6 is compared. So here 8 is greater than 6, hence swapping required. So 8 is replaced by 6 here and 6 is replaced by 8 here. Then the next two elements are compared, that is 8 and 7. So it is also not in the sorted order because 8 is greater than 7. So swapping is happened. So 8 is replaced by 7 and 7 is replaced by 8. Finally, the last two elements that is 8 and 2 is compared. So here 8 is greater than 2. Hence, swapping is necessary. So, 8 is replaced by 2 and 2 is replaced by 8. So, now we reach the end of iteration 1. Even now, the elements are not in sorted order. So, we perform iteration 2 now. So, the same procedure is repeated. So, first two elements are compared, that is 3 and 5. It is in the sorted order, so no swapping has happened here. Then the next two elements that is 5 and 6 is compared. It is also in the proper order, so no swapping is required. Then the next two elements that is 6 and 7 is compared. It is also in the proper order, so no swapping is required. Then the next two elements that is 7 and 2 is compared. So here 7 is greater than 2. So swapping is needed here. So 7 is replaced by 2 and 2 is replaced by 7. Next, the last two elements that is 7 and 8 is compared. It is already in the sorted order, so no swapping is required here. So we reach the end of iteration 2. Even now the list is not in sorted order. So now we perform iteration 3. So here the first two elements are compared, that is 3 and 5 is compared. It is already in the sorted order, so no swapping is required. Then the next two elements, that is 5 and 6 is compared. It is already in the sorted order, so no swapping is required. Then the next two elements, that is 6 and 2 is compared. Here 6 is greater than 2. So swapping is necessary. So 6 is replaced by 2 and 2 is replaced by 6. Then next two elements are compared, that is 6 and 7. So here it is already in the sorted order, so no swapping is needed here. Then the last two elements, that is 7 and 8, is compared, so it is already in the sorted order, so no swapping is required here. So now we reach the end of iteration 3. Even now the elements are not in a sorted order. So now we perform iteration 4. So now the first two elements is compared, that is 3 and 5. It is already in the sorted order, so no swapping is necessary. Then the next two elements, that is 5 and 2, is compared. Here the 5 is greater than 2. So swapping is required, that is 5 is replaced by 2 and 2 is replaced by 5. The next two elements, that is 5 and 6, is compared. So it is already in the sorted order, so no swapping is necessary. Then the next two elements, that is 6 and 7, is compared. It is already in the sorted order, so no swapping is required. Then the last two elements, that is 7 and 8, is compared. Here it is already in the sorted order, so no swapping is required. So we reach the end of iteration 4. Even now the list is not in the sorted order. So now we perform iteration 5. So here, as usual, the first two elements are compared, that is 3 and 2. Now 3 is greater than 2, so swapping happens. So 3 is replaced by 2 and 2 is replaced by 3. Then the next two elements, that is 3 and 5, is compared. It is already in the sorted order, so no swapping is required. Then the next two elements, that is 5 and 6, is compared. It is in the sorted order, so no swapping is required. Then the next two elements, that is 6 and 7, is compared. It is already in the sorted order, so no swapping is required. Finally, the last two elements is compared. It is already in the sorted order, so no swapping is required. So we reach the end of iteration 5 and now we can see all the elements are in the sorted order. So we give the input as unsorted array and we have make it as a sorted array through 5 iterations. And next one, let us see about how the bubble sort coding is done in Python. So initially we have defined a function called bubble sort. So this function takes an array as input. Then it iterates through the array using a loop that goes from 0 till length of the array minus 1, which means this loop controls the number of iterations through the array. Then the variable swap is initialized to false. This variable is used to optimize the sorting process. If no swaps are made during an iteration, it means the array is already in sorted order and the algorithm can terminate yearly. Then there is an inner loop that goes from 0 to length of the array minus I minus 1. So this loop iterates over the unsorted array. So inside the inner loop, the adjacent elements are compared. That is, array of j is compared with array of j plus 1. So if the current element is greater than the next element, they are swapped. So if any swap is made within the inner loop, the swap variable is set to true. If no swaps are made, it means the array is already in sorted order. And the outer loop terminated using the break statement. So finally, the sorted array is returned. So here we are providing the array of elements 64, 34, 25, 12, 22, 11 and 90. So this line, that is sorted array equal to bubble sort of array, This line calls the bubble sort function passing the unsorted array as argument. So this line will return the sorted array. Next, the print of sorted array. So this line prints the sorted array. So that's all about the coding of bubble sorting. Next, we discuss about bubble sort complexity. So here we have three cases. One is worst case, next is average case, and next is best case. So worst case is nothing but it occurs when we want to sort a list in ascending order, but it is arranged in a descending order. So that is the worst case. So the worst case time complexity of bubble sort algorithm is big O of n square. So here this n indicates the number of elements. Next is average case. So it is nothing but when the list is arranged in a jumbled order. So that case is considered as the average case, and the average case time complexity is big O of n square. Next comes the best case. So the best case occurs when the list is already arranged in the desired order. So the best case complexity is big O of n. So the key takeaways from the bubble sorting algorithm is first one, it can compare adjacent elements only. If you have n number of elements, you have to do n minus 1 comparison. And number 3 is it is not suitable for larger data sets. So that's all about the bubble sorting algorithms. So I hope this video opens up a glimpse about bubble sorting algorithm and the concepts behind it. Thank you all. Thanks for watching.